Today we are doing a hard problem number 317, shortest distance from all buildings. Basically we got this map, right? Number 2 is obstacles which we can go through. Number 1 is buildings and zeros are empty cells. What we want to do is build a house somewhere such that if we like the largest distance from it to any from the house we build in a free cell to any of the buildings will be minimal. And of course it's possible that it's not possible, right? If we have everything is taken up by obstacles and or buildings, then we cannot build it, obviously. So this is a classic multi-source BFS problem, that instead of checking for each place how far everything else is, what we want to find is a cell, like we start BFS from all ones, right? And then we get distances to all zeros. And zero with longest distance, that's the actual distance. We should build a house there, and then the largest distance will be like longest distance in the distances, and we don't visit number twos. Simple as that. So let's do nm len grid 0, then we do has empty will start with false and q will be dq this, and then if grid ij is 0, then has empty true. If grid ij is 1, then q append ij, then we need some sort of distance matrix. Right, and then actually I need to declare it here, because distance of ij if it's a building is 0. And then answer is, so if not has empty, return false, otherwise while q, answer is this, and then CICJQ pop left, right, since it's dq, dx dy. So we try all neighbors. So simple in Python. New I, new j. Don't be confused by my name conventions. This ij and grid ij is 0, then dist ni, and so yeah, here I'm using ni and j, but it's actually just ij and it's ni and j, so this is dist cicj plus 1 and q append ni and j. And then we can do one thing. So if grid CICJ is 0, then ans max ans this CICJ. That's weird. Why is it 7 here? Oh, it's not as simple as that. Total distance, okay. Well, then I guess that's here. I mean, there could be like too many buildings, right? It's 50. It's 1250. No, 2500 squared. Oof, that's a lot. I'm not sure that would pass. Okay, it's not as simple as that. And I want the shortest. Okay, so I have the logic completely backwards. Okay, well, and then at that point, let's see. A position to which distance sum of distances to everything else is minimal. Whew. Okay, well, that's tougher. Well, what about is still the multi-source BFS, like what does it do? In this case, that would bring us some vertex that is at distance 2. That's way too far. So we actually don't want that exact vertex. That sucks. No, it can't be just that. And there is no hint, which sucks, but shortest total travel distance. Because launching BFS from every empty node is also pointless. How many buildings is there? But 2500 is 125,000, so that's 60 million. I mean, theoretically, it works. Theoretically, but that's just a theory. A food theory. Dun, 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 dun. Okay, I will shut up now. Okay, then so this will be sum of distances, why not, right? Or I will put just this here. Okay, I need to increase the size of this a little bit. This is also bothering me. So if this is the case, right, then we just do this. Let's call this like inf, which should be like this. This CICJ plus 1. We do this, and then we need to have some total dist. So basically what I just do here is total dist CICJ total okay. Ten? No, hell no. If total dist return answer. What the hell? Grid ij is empty, so basically we go over empty cells. Why false? I mean, this should not work. If this passes time limit, this should get time limit exceeded. What the hell? What? So basically this should work. Okay, so if we didn't find anything suitable, total dist ij, and I have fly inside of my room. That's gonna be so annoying. Something wrong with this. Oh, also I have to also check this. Oh my days, bruv. If not one component grid def one comp self grid list int. What that means is we just run DFS from first. All need to be reachable, right? So we run BFS from a first one we encounter. So I'm just gonna eat this. So technically I don't even need it. So what I need to do is, if we are 1, I use it. So basically let's copy this whole flow. Ones is sum of grid ij1 for j in Okay, so that's ones. And then whenever we visit A1, send ones. If grid CICJ1, then send ones plus equals 1. Send ones 0. Whatever, I guess. And now if send ones don't equal, return send ones equals ones. Let's see. If it's not 2, okay, that works. So basically I just check if all ones are reachable, and now I will pass 19 cases instead of 18 for sure. Wrong answer here. Why? Okay, so it didn't happen here. Okay, so somewhere here it happened. What? Not even here. What? Now I have two of same watts. Let's see which one it is. Okay, so it's this watt. So somehow something happened here. Grid IJ is 1, so print sent once. So just show me that, no? What's up with that, bruv? What the hell? What's wrong with this? No cell. What? Okay, that's just crazy, bro. Print IJ, grid IJ. So I'm overwriting something in here. I must be. Free. What the hell? Oh, I have this return iteration early. Okay. Let's see, there is some print. Now this should get time limit exceeded. Wrong answer here. If this doesn't equal this, and otherwise, now I have to pick some SI if grid SI SJ is 0 and this SI SJ is not 0. Okay, then we need to do this whole queue thing again, and we need to check. Okay, so we put SI SJ there. SI SJ. SISJ. Now I don't need count once. Let's call it this too, why not? If grid CICJ we don't do anything, right? So I start BFS from zeros, and whenever we get to 1 we don't do anything. And then at the end what should happen is that for XC in range N, for XJ in range m if dist xj don't equal -1. No, I want this 2 xj should be these two, these two, these two, these two. Then isn't this like 10 nested loops? That's straight up ridiculous. For row in dist print row don't equal -1. Let's see. Okay, now a mistake is just here. Doesn't make sense. Why should I return here? No, still doesn't make sense. So I am here, then I should be at here 2, here 3, here 4. This was the bug. No, here 1, 2, 3, so I never get to here. Let's see it. Okay, now it passes everything. Okay, let's see. Probably again some edge case wrong. Or now I will get time limit exceed. What the hell? I'm gonna piece my piece, bro. Okay. Okay, so let's continue with this painful problem. Since it's been half an hour, I took a peek at like editorial, and basically it was brute force. I'm just bullshitting here extremely for some reason. Anyways, First I visit something from the middle portion. That doesn't make sense. Overcomplicating, right? Don't know where this ends though. Here, okay. Okay, now this doesn't work. That's great. Let's see about this one. If we are not at the starting one, then we continue. And now this case doesn't work. That's awesome. Yeah, I'm doing it in the wrong way. This whole shtick. You know, I'm gonna move test cases here so you can see the code, but basically this is useless completely. Okay, new strategy, which should be simpler, is that basically we also have like a count that reach it, right? So 0 for j in range m, for I in range count ci cj plus. Okay, if grid ij is 1 and I need count of ones, so and now how many ones can reach this? So and count ij skipping this. Come on mate, pass now please. If this gives TLE now after 10 tries, let's go. There is no way it actually worked. Oh my days, bro, so dumb. so just run a BFS from each building and add together distance matrices of each DFS of each BFS, and then for each empty cell check if it was reached by all reached from all buildings, and if yes, consider it for the final answer. Where n is the number of rows and m is the number of calls, since we run a BFS from at most O&M cells and each BFS takes O space complexity O&M, since we have matrix for total for sum of distance matrices and a count matrix how many buildings can reach a given cell, and finally we have the current BFS distance matrix. Okay, so much time spent on this garbage, whatever. Okay, see you tomorrow.